Greetings of the day. Myself, Saurabh, Senior Assistant Professor, Department of Mechanical Engineering, ABES Engineering College, Ghaziabad. I'm here to represent my video lecture series on graphical representation of stresses on inclined plane. It may also be stated as Mohr cycle construction for a body loaded under tensile or compressive stresses and the stress generated inside the body through geometrical construction method. Moving further, Mohr cycle construction is categorized in 5 ways. That is unidirectional loading, bidirectional loading for the like stresses, bidirectional loading for the unlike stresses. What is the meaning of like and unlike? Like stands for same nature of stress is acting inside the body or on the body. Unlike stands for nature of stress is different. You may say that tensile as well as compressive stress acting simultaneously on the body. The fourth category is bidirectional loading, whatever it may be, like or unlike, along with a shear stress. And the fifth category is principal stresses. Moving further, in, to understand the construction of first category, and that is called unidirectional loading. What is exactly unidirectional loading is? Unidirectional loading stands for, suppose that this Earth is a three-dimensional object and it is loaded in only one direction. Either it may be in x axis or x orientation, or it may be loaded as in y direction. If it is loaded in the same direction, it is called unidirectional loading. To move further, it's better to fix the sign convention. Positive x stands for tensile stress, while the negative x stands for compressive stress. Same as with the y as well as positive y and negative y. But as we are not talking about bidirectional loading system, we can eliminate loading on the y-axis for now. To move further, to understand the construction philosophy or method, or you may say steps, we have to fix this loading condition with a certain example having a numerical value. You may say that, suppose the direction of this stress having the magnitude of 500 Newton per mm square. As the direction of this stress is in x, it can also be written as sigma x. And sigma x is equal to 500 Newton per mm square. Definitely, for being this body to be in static equilibrium, that value must be of same magnitude with tensile nature. Right? Now, what are the basic steps to construct Mohr cycle diagram? Number one, draw a simple xy axis orientation having origin at O. Step number two, scale down or up the given stress, which is in this case sigma x is equal to 500 Newton per mm square into a suitable scale as per size of your paper. the paper which we just generally use is A4 of size. So we may take 10 Newton per mm square is equal to 1 mm. So sigma x with the magnitude 500 Newton per mm square is converted in a scaled down value of 50 mm. As 1 mm is stands for 10 Newton per mm square, then 50 mm stands for 500 Newton per mm square. Now, moving further, the origin, the value of sigma x we have taken is of 50 mm. That is scaled down value. So that we can represent a stress magnitude on a linear scale. Now, mark the length 50 mm in this scale and put the value as sigma x. Mark it as a point A. Now, the third step is two steps has covered. First is the drawing the origin as well as xy in xy pattern. Second is scale down the stress value on a linear scale. Third one is bisect this length OA. Bisect this length OA. Step number three. Step number three stands for bisection. Step number four stands for now with the radius as this bisection marked or bisect this line OA with point B on x-axis. Now measure the value either OB or BA as a radius and draw a circle. Now we can see that in previous phase that this is our example, or you say that is our body, and we have to find a stress. We have to find the stress on an inclined plane, which is oriented at an angle of theta with respect to direction of normal stress. So in two-dimensional frame, we can see that that is the value of or direction of sigma x, and that is the angle theta. Or you may say we have to find the value of stress on a plane which is inclined with respect to direction of sigma x, or the stress which is acting inside the body. This theta is the orientation of that plane for which we have to find out the value of stresses. Now, step number four is locate the particular plane on which stress is to be calculated. And for this, we have to draw a line at an angle of 2 theta from that particular point B in the direction having the orientation of that particular plane with respect to stress generated, or you may say stress acted on this particular direction, and that angle is taken as 2 theta. Draw a line with the marking angle 2 theta in anti-clockwise direction, that line intersect with this circle at point C. Now, step 4 is angle marking the angle. Step number 5 is draw perpendicular. Draw a perpendicular from that particular point C on this x-axis and mark it as a D point. Draw perpendicular with addition, marking point D on x-axis. Now, the sixth step is join the line O and C. Now, join O and C. The results are final to be came right now. Now, the value OD will be 7. The value OD will be the normal stress generated inside the plane, while the value CD is shear stress generated on that particular plane. The value which we have find is on a linear scale. That will be the value will be we can measure it in mm OD. The value of OD is suppose that x mm, and the value of CD, or you may say tau. And then this value is shear stress, and that value is normal stress. That will be x mm, and suppose that tau is the value of with y mm. Now moving further, how can we correlate that our answer is right and the construction which we have drawn is correct? To analyze a system, to analyze a three-dimensional body, we have exactly two systems for the to find the value of correct stress with their magnitude and direction. And the first one is conventional method, and second one is graphical method, or you may say Mohr's method. So the conventional method, which we derived for a body under bidirectional loading system for the like stresses with shear stress acting on the body, is like that. Sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta, while tau on that particular inclined plane is equal to sigma x minus sigma y divided by 2 sin 2 theta minus tau xy cos 2 theta. That is the general results for this particular body. Now, could we compare our body, which we have analyzed earlier in this case, with this loading system? We can easily see that is the unidirectional loading system. So, sigma y as well as tau xy is 0 in this case. Now, if this value is 0, we can easily calculate sigma n is equal to sigma x divided by 2 plus sigma x divided by 2 cos 2 theta, and tau xy is 0. Now, sigma x divided by 2, 1 plus cos 2 theta, or you may say 2 cos square theta minus 1. 1 is cancelled, 2 is cancelled, and the value of sigma n is sigma x cos square theta. right? Same as for the tau. You can easily calculate the value of that one. Now, moving further, what is the value of this sigma n with respect to that diagram? The value of sigma n is simply C. We can see that sigma n is nothing but that is OB plus BD. And the value, what is the value of OB? And the value of OB is sigma x divided by 2. The whole length of OA is sigma x, and the length of OB will be sigma x divided by 2 plus BD. BD is what? That is BC cos 2 theta. And BC is radius of the circle, same as OB is the radius of the circle. It can also be stated as sigma x divided by 2 cos 2 theta, sigma x divided by 2, 1 plus 2 cos square theta minus 1. Or you may say sigma x cos square theta. So, results for both analytical method and graphical methods is same. We can also verify for the value of shear resistance 2 with this method. So we can see that in spite of deriving and memorizing this detailed and little bit tough formula, we can easily draw more circle construction for such type of loading condition. Hope you all people can understand very well in this video lecture. We will move further for the next type of construction and try to correlate with the result available from traditional or conventional analytical method with Mohr construction method. The references I have taken from these two textbooks, and the name of books is R.K. Rajput and S. Ramamurthy. Thank you. Thank you very much.